Alright, in this video we're going to see how just from the sides of a triangle you can figure out if it's going to be acute, obtuse, or right. So let's look at this first one. We have 6, 8, and 10. So what you want to do is identify the longest side and kind of put that on the side. And we're going to say, okay, 6, 8, and 10, so what does that triangle look like? So 6 squared, we're going to do 6 squared plus 8 squared equals 10 squared, or question mark, does it? So 6 squared is 36, and 8 squared is 64. And 10 squared is 100, this is absolutely true. So this squared plus this squared equals this squared. This should look familiar. This is something that is true of a right triangle. So if you have a right triangle and you have the two legs of the right triangle squared, the sum of those, if it equals the hypotenuse squared, we know it's a right triangle. So because 6 squared plus 8 squared is 10 squared, we know this is a right triangle. So anytime if you look at the sides of a triangle and the two smaller ones, the sum of their squares equals the square of the bigger one, it's a right triangle. Now right triangles are rare. You know, it has to work out perfectly, but this is just sort of to set the baseline. So now the question is, okay, well what if we had the same two lengths for the legs, but a different longest side? And this is still possible because 6 plus 8 is 14, right? That has to be bigger than the longest side. So what would happen if this side, which is 10, were lengthened to 12? What would happen? The triangle would open up. You know, the only way this would work is if this were like this were 12. So if this were 90 degrees, this must be over 90 degrees because otherwise how else could you construct this triangle? So what this says essentially is if a squared plus b squared, if that is smaller than c squared, then you are going to have an obtuse triangle. Or put another way, if the longest side squared is bigger than the other two sides squared, it's obtuse. So the best way to look at this is, you know, compared to the right triangle, when they're equal, if you open the triangle up more by making the longer side even longer, it's going to be obtuse. Alternatively, we have our 6 and 8. What if we shrank this 10 to a 9? That would shrink the triangle a little bit, and it would be acute. So if a squared plus b squared, if c squared is less than that, then it's going to be an acute triangle. And that's sort of how we classify these triangles. So we just have to take the longest side and compare it to this, you know, the two shorter sides. So let's see this in action. So here, 6, 3, 5, let's identify the largest side, which is 6. So we're going to say 3 squared plus 5 squared. How does it compare to 6 squared? So 3 squared is 9 plus 25, that's 34. 6 squared is 36. So the longer side squared is bigger, so that means this is obtuse. So again, if the longer side squared is bigger, it's obtuse. Here, the longest is 13, so we have 5 squared plus 12 squared compared to 13 squared. 5 squared is 25, 12 squared is 144, 13 squared is 169. Well, when you add these up, these are equal. So this is actually a right triangle, one of these rare cases where a squared plus b squared equals c squared. And here the largest is 9, so 4 squared plus 6 squared compared to 9 squared. 4 squared is 16, 6 squared is 36, which is 52. 9 squared is 81, which is also bigger. So this is going to also be obtuse. No acute triangles in this situation. And that is pretty much it. So that is how we classify a triangle as acute, obtuse, or right. And again, we have to assume these triangles exist, right? So if you add up the two smaller ones, they should always be bigger. So 3 plus 5 is bigger than 6. 5 plus 12 is bigger than 13. 4 plus 6 is bigger than 9. That just proves that the triangle exists, like from one of our earlier videos. But anyway, until next time, I am Derek Genova. Have a delightful day.